Hello, everybody. It is now 12:30. Hello, hello. Come on in, come on in. There's granola bars in the front. As always, please go ahead and get some if you'd like. Welcome back to CSE 8A. Today we're going to be covering something called functions. Now, just as a quick, to get ahead of it all, functions are like the first big step up that we're going to be doing. But we're going to make sure that it's nice and simple so that we get started. But functions is something that if you continue on with your computer science career, you're going to be using functions all the time. Okay? This is like one of the key fundamentals of computer science. Right? So, but before we get into that, some announcements. Lab 1 happened yesterday for Onshore section, correct? And we had our lab on Monday. And the PA1 was released yesterday, and it is due Monday for July 7th. So please get started on that earlier rather than later, so that if you have any questions about the content, how to proceed, you can always come to any of the office hours, any of the help hours that we provide. Okay? Also, if you have any conflicts with discussion times or exams, especially exams, all right? If you have some sort of conflict, please let the instructors know as soon as possible. Because if you're not going to be able to make it to our final exam or midterm exam, we need to know that as soon as possible so we can create that accommodation for y'all, okay? And also, something new, discussions and labs will be combined now. So, as I said before, Lab 1 for Anshal's section was yesterday, but now we're going to be combining our sections together. So I sent out that poll for all of you to fill out, and all of you either said that yes, you're okay with the change, or you have no preference on making that change. So we will be making a change now. Anshal section will have no change, but for us, our discussions and labs are updated on the course calendar. So basically, we used to have labs on Mondays and Wednesdays, now labs are Tuesdays and Thursdays. We used to have discussions on Tuesdays and Thursdays, now they're Mondays and Wednesdays. So for today there will be a discussion, all right? Not a lab, a discussion. All the changes have been updated on the website, all right? On the course schedule and on the course calendar, all right? So if you have any questions on that, please let me know. Does everyone understand what we're doing today for discussions or labs? Yes? Great, fantastic. So now, instead of having just our 5-person section for labs and discussions, we will now be in a larger section altogether, right? Yes?
What room are the discussions and labs in?
Yes, so labs are going to be in the same room, right? Or in the same room location in the computer science building basement, right? We used to be in B260, now we're going to be in B250. It's just right next door, okay? And then also for discussions will be in a new place. Instead of that being in the Design and Innovations building, this will now be in Pepper Canyon Hall 120. Okay, Pepper Canyon Hall 120 is very close by to here. It's only like a 5-minute walk. But again, all of that should be in the email that I sent out and also on the website. So, but thank you. Great question. Okay. Any other questions on that? Yes, no, yes, no? Great. All right. So, as always, we have the lecture participation form. You could start with this. However, I think it might be more beneficial for us to look up on an EdSTEM workspace. So right now, on EdSTEM, we have provided now a lesson. The lesson is called Lecture 3 for today. Okay, so if you go to EdSTEM, actually I'm going to open that up right now. If you go to EdSTEM, right, this is the opening of EdSTEM. Oh, speaking of, also on EdSTEM, in the discussion, I think I mentioned this yesterday, but if you feel a little bit nervous about asking a question, you don't want to raise your hand, that's totally fine. We have a discussion post here called Lecture 3 Questions for 12:30 p.m. lecture, and you could ask your question there. You could ask it with your name or anonymously, and we will get that question answered. But for our lecture here, if you go up here to where it says Lessons, right? Lessons is going to have a bunch of different information, but you can go down to where it says lecture activities. And lecture activities, there's lecture 3. I added a couple comments for myself, but for you, you should probably have a blank file called notes.py, right? So let's continue on. Oh, also office hours. Make sure to go to office hours, as we said before. If you're going to be working on your programming assignment, please work on it sooner rather than later. But our course calendar is here with all the office hours, for everybody. It's got this like little pinkish, orangish color. It's called flamingo. But I just had my office hours later on today. Kristen will have office hours, so will Chao-Hui, and Kevin, and lots of great, wonderful tutors and TAs. Okay? So, please, please, please go and get help whenever you need it. All right. So, last class, yesterday, hopefully y'all got to see the video on it, so you could get back up to date with what we're going with. But we covered something called expressions, right? Basically writing stuff out into the terminal or onto your Python file where you can actually make things, right? You can make long sentences using strings. You could use it as a calculator doing math operations. And speaking of operations, there's the order of operations. PEMDAS, as many of you may know it by, parentheses, exponentiation, multiplication, division, addition, and subtraction, all that in that order. Make sure to look at the lecture yesterday. The recordings are on Canvas, so you can go look at the recordings that we had for yesterday. We also looked at data types, different data types that we had, integers, floats, and strings. We're going to be using a lot of this today, as well as variables to store information. And we also got some input from the user so we can actually communicate with the computer, right? And then we also very briefly covered type conversions, right? Grabbing some sort of data and morphing it into something else, right? Getting something like an integer and morphing it into a string, or vice versa. Okay? So, those are some of the ideas that we covered in class. And since we very barely covered type conversions yesterday, we're just going to cover it right now. So, in Python, we have all these different data types, right? We have floats, we have integers, we have strings. There's others, but right now let's just focus on those 3 that we've covered so far. Okay? And we know that integers, such as 42, 42 is an integer here because it is just a number without a decimal point, right? So this is just a pure, vanilla whole number. Then we have CSE 8a, and this is a string. And a string, how do we make strings again? How does Python know that we're looking at a string? Yes, the quotation marks, right? Yeah, the quotation marks. And we have 2 here. We must have 2. Is that true? Yes or no? Yeah. We need 2 quotation marks. Maybe I didn't say that right. Yeah, I think I didn't explain myself. Yes, we need quotations at the beginning and we need quotations at the end, right? Should these quotation marks, they be double or single quotation marks?
They can be either.
They can be either, right? Python will know that whether you do single quotation or double quotation marks, it'll be a string, okay? But yes, I don't know why I asked it that way. Yeah, you do need to open it and close it, right? You have to have a start and an end to your string. Then, lastly, we have floats, 3.14. Floats, again, they are numbers as well, but these are numbers with decimal points, right? So 3.14, we know this is a float because it's got that decimal point and some more numbers after that. Even if you have 14.0, is 14.0 an integer or a float? A float, right? So it doesn't matter whether 42 or 42.0 are the same number, right? They mean the same thing, but they're 2 different data types. One is an integer and one is a float, right? And now we can convert between these different types, right? So now what you can do is we have these keywords from Python that we mentioned yesterday, right at the end, right? Int is integer, float is float, and str, that's string, right? So when we have these int, floats, or strings, we can say, I want to make something into an integer, right? And the thing that I want to make into an integer, I'm going to give it to you right here, inside these 2 parentheses, right? And so now anything that's inside these 2 parentheses Python's going to try to make this into an integer, right? So it grabs this 3.14. What type is 3.14? It is a float, right? And now we're going to try to make this float into an integer. It's going to grab this 3.14 and it's going to morph it. It's going to grab it and squeeze it and try to make something else into it, right? And we make it into an integer. And the way that it does that is it drops everything after that decimal point, right? So it goes from 3.14 to 3. Same as if we were trying to do an integer to a float, right? We have this float, so we're going to try to make this 42 into a float. And the way we do that, again, we put the number inside the parentheses, we try to morph it, and it becomes into 42.0, right? Same number, but different way to represent that number as a float. And then lastly, strings, okay? We have this number, 2022. Is this an int, float, number? What is this?
Integer.
It is an integer, right? 2022, there's no decimal point. We get this integer and we tell it, Python, can you please make this 2022, which is an integer, into a string? It says, you got it, I'm gonna grab it, I'm gonna morph it, I'm gonna make it into a string here. Okay? This is single quotes. Again, even though it's single quotes or double quotes, they are strings. Does that make sense? Yes? Any questions so far? All right. So, we can look at some of these type conversions, right? Let's do it right here in our little terminal. So, as we showed before, when I write Python into the terminal, I just click enter, and I have this pop up. What is this called again?
Prompt.
A prompt. Yes, this is a Python prompt. So we can start adding a bunch of different things. And what's the difference between a prompt and a file?
Once you close a prompt, everything is erased.
That's exactly right. As we said yesterday, when you have a prompt, you can write as much as you want. You can write a billion, million lines of code in here, but it's like scratch paper. As soon as you finish with it and you close it up, you crumple it up and you throw it away, right? And you're not going to be able to see it anymore. Right? So anyways, we're now in the Python prompt, and we can do this int, right? Let's try to make something into an integer. Someone give me something. What do we want to make into an integer? 42. Point oh. Let's see what happens when we click enter. 42. Great. What if we want 42.9? What's going to be the answer here?
42.
42. Boom. 42. Because, like we said before, Python, when it gets a float and you want to make it into an integer, it's just going to say, great. I'm going to look at the decimal point. I'm going to ignore anything after it, right? We're not rounding or anything. We're just going to grab it and remove it, okay? Let's see float. What do we want to make into a float? Any number.
49.
49. Let's see what happens. 49.0, right? It just provides us with that decimal point, okay? What if we do this? 49 as a string. Can we do that?
Yeah.
Why is that?
It's a number inside.
It's a number inside. Let's look at that. That works. Let's do another number inside. CSE 8A. There's a number inside here. 8. What will we get?
An error.
An error? Or would we get 8.0? Let's try it out. I don't know. Let's click it. Oof, we got an error. Okay? The reason for that is because it says I can't make this string that you gave me into a float. Okay? Python will try its best to make something for you, but you also have to cooperate with it, right? You can't say, here's CSE 8A, make that into a number, right? Make that into a float. It can't do that. Unless you give it something that it can recognize as a number, right? So here, float of 49 is a string. Python can see the string, read it, and say, everything inside this string is a number. So I can make this into a number for you. As a float, here you go, right? But when it's CSE 8A, it cannot do that. Does that make sense so far? Yes? Great. And then, same thing with string. If we do, let me clear this up. So if we do str, what do we want to make into a string? A really big, fun number. Any number, at all. Someone in the back. Give me a random number. A big, large number.
420.
420. Oh, nice. Okay. All right. So if we do 420, we click it. So str 420 goes into 420 as a string. Okay, as a string. Because Python is saying, okay, whatever you gave me, I see this as an integer. I can make an integer into a string pretty easily. Let me just put 2 quotes around it, and we're good. All right? That makes sense? All right? Let's actually exit out of this. Clear out. Awesome. All right, so that is type conversions. Any questions on type conversions? No? We're all experts on type conversions now. Yes?
Yeah.
Awesome. Great. We have a midterm right now. I'm just kidding. Come on. All right, but we do have a question. So, we have a couple of type conversions that we have here. Which among the following type conversions will result in an error? I'm going to give you all just a couple minutes to think it through. And then we'll see what it may be. All right, so which one of these is going to give us an error? Python's going to get mad at us and say, what are you doing? Why are you giving me this? I can't do this. It's going to give you an error. Which ones will we get an error on? Yeah?
4 and 5.
4 and 5? Okay. Why not 1, 2, and 3? Why wouldn't those give us errors?
Like they're all numbers.
They're all
The
numbers?
first 2, they're both numbers, and then the third one, like anything can be turned into a string.
Anything so far can be turned into a string. I won't just say that everything will be turned into a string. But everything so far that we've seen could be turned into a string. Why don't we try this out? Okay? Let's try it all out. So, first thing we had was int. Wait, did we have int of 420 here as well? Oh, okay. Int of 420. Okay. Put that in there. 420. That worked out well. What about this one? Float of 42. Oh. I forgot to close my string. Remember, always have to open and close your string. You open it with one quotation and you end it with another quotation. Okay. 42.0. That worked out well. What about this str 4.12? That worked well. How about this int 1? So you said that there's no number in here, but there is a number here. It says right there, 1.
That's like spelled out, so.
It's spelled out. But is Python going to know that 1 is a 1?
No,
Why not?
it just doesn't know.
It doesn't know. But there's a good reason why it doesn't know, right? We'll try this out and we get an error, right? Why should it be that this turns into a 1, right? Like if I was trying to create Python, I'm like, we all know what 1 is. Let's just make 1 a 1. Why can't it just evaluate it into 1? What if I tried to do this instead, right? Instead of, wait, what was it? Was it int float? Int of 1. Instead of int 1, What if I tried this? Int uno. Uno is also 1, right? Why wouldn't that work? I run that, it's not working. Okay. What about int un? That's 1 in French. Would that work? No. Right? So that's another reason why this would not work either. Yes, we're working in English, right? Integer, float, these sort of things. But is Python going to know every single language out there known in mankind about this? No. Okay? So therefore, these strings, right, even though they may look like there's a number inside, 1, just because it looks like it's a number, just because we can read it as a number, doesn't mean that Python can also read that as a number, right? All right, so it has to be the numerical value, not written out. Okay? And then lastly, float of pi. Let's try that out. Float of pi. Pi is a number, isn't it? Pi is 3.1415926, and then I stop because I don't know anything after that. Does anyone know pi? I don't know pi. I know some people that knew like 200 integers of pi. It's wild. I could never do that. But anyways, let's try this out. Let's run it. Ah! We don't get it. Unfortunate. But for the same exact reason, right? For the same exact reason. Python's not going to be able to see pi, read pi, understand what pi is, and give back pi to you. Right? It's just not feasible for Python. Does that make sense, everybody?
Yeah.
Awesome. Let's exit that out. All right. Cool. Those 4 and 5. Oh, coding activity on S10. That's what we were doing really quickly. All right. So we were here. Let me clear this up. So we also have this other question for you. We were talking about storing information into variables, right? When we're storing information into variables, we can put some nice whole numbers in here, but now we're setting a variable to a different variable, right? We're setting one variable to another. So x is 10, but now y is equal to x. At this point in time, what is y equal to?
10.
It's equal to 10. But now we're going to say x is equal to 20. What's the value of y? Are we going to get 20? Are we going to get 10? Or are we going to get an error? 10?
10.
Sorry?
10.
10? Why wouldn't it be 20? We're saying y is equal to x.
Because you change the value of x, not y.
You change the value of x, not y, but y is equal to x. So should it be 20 or should it be 10? Or are we going to get an error?
10.
10? One of the best ways to find out is to just try it out. Let's do it. Right? So we make x equal to 10. Right? We say y is equal to x. If we were to show y at that point in time, right? Y is 10. Now let's make x equal to 20. We print out x. X is 20. Y is 10. Okay? So yes, because we were looking over here, y at this point in time is going to say, I'm going to look at what x is at this point in time. Whatever it is, I'm going to grab it, and I'm going to store it as well. Right? Then we get y is equal to x, which was 10. What if we were to put y is equal to x again? What's going to happen now? What is y?
20.
20.
20. Right? Isn't that crazy, Noah? Wow. Yeah, that's crazy. Anyways, so when we're working with variables, remember, we say when we're setting a variable, right? We're setting x to be equal to 10. When I say anything to the right of this, we're gonna sort into x. And that was 10. Y says anything to the right of this, we're gonna make into y. We see that it's x. What's x again? It goes and checks, it's 10. Okay, y is 10 now. Okay? And then same thing with x. X used to be 10, but that doesn't matter anymore. Because we're going to make X equal to something else. We can make it to 20, we can make it to the string of 20. We can make it the string of Ismael, right? But in this case, we're putting it to 20, and then X is 20, but Y is still 10. Alrighty? Sound good? Alright, now we're going to get into functions. Functions in Python. Using built-in functions. You've been using functions this whole time. They've been sneaking up on you. Right? You've been using functions all of yesterday. And a little bit the day before. We're also going to be able to write our own functions. How to make them, how to use them. We're also going to learn in the order of which functions Python is reading them. We'll get into that right now. And also the difference between printing and returning. Don't be worried, we're going to cover all this right now. Know also that printing and returning, this could be a little bit difficult for people to comprehend right out of the get-go, but we will do it very quickly, very slowly to make sure that we all understand what's the difference between printing something and returning something. So, a function. Functions in Python, right? A function is basically something, is like a pre-written code that's been made that you can keep on calling over and over and over and over again, okay? And you could, instead of having to basically copy-paste everything that's inside, like some sort of operation, right? You want to do steps 1, 2, 3, 4, and 5, but you want to do steps 1 through 5 like 10 times. So instead of copy-pasting steps 1 through 5 10 times, you could all fit it into something called a function, right? Functions are going to be able to hold a bunch of code and just wait until they call on them and say, hey, function, I need you to work right now. And the function is going to be say, sweet, I'm here. I'm going to run all the code that's inside, right? What does that look like, right? What does this look like? So a function, let me put this down here. How do functions work? So let's say that we want to get the area of a circle. We have the area of a circle right there as an example. And actually, I'll get that when we start looking into, sorry, forget the area of a circle. We'll get into that right now. But how do functions work? So basically functions are going to be able to hold a bunch of code. It could be like 2 lines, 1 line, a million lines of code. And it's going to sit there waiting for us so we can go and ask it to run itself. What is that going to look like? It's going to look like this. Okay? So functions, there's like, as we said, functions have a lot of pre-written lines of code. And there's some things that we've already been using that are pre-written lines of code. Something like print, right? Print is a function. Bet you didn't know that, right? This print function basically has a bunch of information inside it, and we're going to give it something, right? We're going to say, what do we want to print out? What if we want to say, hello to all our lovely staff members that are sitting in the back of the room, right? What if we want to say this, right? When we run this, Python's going to understand what we want and give it to us, right? But a function works really well when we start to interact with it. And the way that we can interact with it is something that we saw in past lectures of, actually, I don't have it up here. But this is a good representation of what we mean. In the past, we said that programs, right? You need to give it something, it's going to do something with it, and it's going to give something back to you, right? That's what we knew of programs in general. Functions are the exact same way, right? You can give something into a function, and you're going to say, hey, function, I want you to do something with this, right? Function's going to say, cool, you got it. I'm going to do something inside here, whatever it is that I'm supposed to be doing. In this case, let's look at print, right? Print is supposed to do something. Print is supposed to say, hey, I got something. I'm going to show it to you down here. I'm going to show it to you in this console down here. And once it does what it's got to do, it gives it right back to you. This is an output. An output. Okay? So first you give it something. That's the input. Hey, function, here's this. We gave it a string, right? We gave print a string. Print says, you got it, I'm a function, I'll do what I gotta do. It does some magic in the background, and then it gives you something back, right? It says, here you go. You wanted me to put this out in the console, here it is, right? And that's the output. Does that make sense so far about what functions look like, what they mean, what they do? Anyone confused at all? No questions? All right, great. So that's what functions look like, right? Oh, actually, I'll comment that out for now. Okay. That's what functions look like. What do functions do? How do functions work? Anyone? We just covered it. Yes?
Like you put something in and they do something.
Yeah, you put something into the function does something with it. Then what happens?
Maybe it returns something.
It'll give something back to you, right? It'll do something and give something back to you, right? So, that's how functions work. But, we've been using functions this whole time, right? We've been using functions this whole time, such as print. Print we've been using, and we say print, we're going to give you something. And whatever we're going to give you is going to be inside these parentheses. Let's say let's print out 27, right? Let's run that. Boom, 27. Fantastic. But we also have this other thing called input, right? Input is also a function. And input's a little bit more involved than print, right? Because now we're going to be getting something from the user. So let's use the input function. What do we want to ask? Anything at all? Anyone have any deep, dark? Anyone have any deep questions to ask to the user? Are you thirsty? Are you thirsty? Right? We're going to ask that. Let's run it. Boom. It looks very similar to what print was doing, right? We gave it something, and I put it down here, but it's not done. This function is not done yet, right? And now we're saying, are you thirsty? I'm going to say yes. Yes, I am thirsty. Boom. Right? And then now the function is done. The function finished doing what it had to do. But as we saw before, with input, usually you want to store that information for something else. Let's call this answer. So, yeah, and let's make it put a little space right there to make it look nice. Are you thirsty? Yes, I am. Right? So now, this input function said, you got it, I did what I had to do. And I stored whatever I had, I grabbed something, and I put it somewhere else. Where did the input put their information? So this yes, where is this yes stored at?
Variable.
Into a variable called answer, right? So input heard what the user had to say. The user said, yes, I am thirsty, and put it into answer. So now if we want to see answer, we use a different function called print, right? So now if we run it, and we say, are you thirsty? Yes, of course. I'm famished. I cannot believe famished. Is that the word? I don't know how to say it. I'm super thirsty. I haven't drunk any water in days. Oh gosh. Boom. Here's the answer. The answer is exactly what we typed in, right? So this function, input will get whatever the user wants to say, grab it, and give it to somewhere else, right? In this case, we're giving it into this variable called answer. Right? Does that make sense so far? Yes, yes?
Yeah.
All right. Oops. Yeah. There's also other built-in functions that we could be looking at. Some things that we haven't used yet, but are very useful whenever we're working with programs. One of them is called max. Max is something that grabs numbers and gives you the max number, right? It's just going to give it back to you. So let's say, since it's going to give it back to you, Actually, let's shout out some numbers. Someone say a number, any number whatsoever.
50.
50. Another number.
20.
20. So when we run this, what's going to happen? Well, let's try it out. Whoops. Let me run that. Seems like nothing happened. The reason for that is because Max is doing something very similar to what input was doing. Remember input? Input would get some sort of information and say, I'm going to put this information somewhere else. Right? And we had to catch that answer of yes, I'm thirsty, and put it into answer. So now, we have to do the same thing with Max. Max is going to return something to you. He's going to grab an answer and give it to you. But if you don't do anything with it, it's just going to fall and it's just going to be gone. So, Max answer. We can call it like that. Let's run that. Nothing happens. We have to print it. Max answer. We run that. Boom. 50. Right? So now, this max function, you get some numbers, it looks for the largest number, and it'll give it to you. Okay? Give me a different number. Higher than 50. 80? Good number. Let's try that out. Now when we run it, boom, 80. 120. Get some 120. Okay? So that's how max works. Something very, oh sorry. Right now what I just did, I highlighted these things and I did command / and that'll just comment things out. You should have learned about comments in the lab from Monday. Right? Okay, good. Thank you, Audrey. All right, there's a very similar one called min. What do we think min is going to do?
Smallest number.
The smallest number, the minimum number. Someone give me two different numbers.
50 and 20.
50 and 20. Fantastic. Let's print that out and see what happens. We run that, and we get 20 now. Give me a different number. Something lower than 20.
10.
10. Now we have 10, right? What if we do this? Negative 20. Run that. Boom. Negative 20 is lower than 10, right? So it keeps on lower, lower, and lower. Negative 5 or negative 2. Negative 2. Okay. Min is just going to give us the minimum of these numbers. Does that make sense so far? Yes, yes? Okay, cool. Sum. Sum is another math function that's going to be super useful for us in the future. We're going to make something very similar to sum right now in this class. Like make it ourselves. But for now, Python has something that's already made called sum. So what do we think sum is going to do?
Add.
It's going to add some stuff together. Some answer. So, somebody give me some numbers that are not 10 and 20. Or 20 and 50.
18 and 53.
18 and 53. Okay. Let's run that. Oh, int object is not iterable. Whoops. What's going on here? Oh, geez. Sorry. Sum isn't working. Why is that? Well, functions are very particular and very, very, very picky. And if you don't give it exactly what that function wants, then it's not going to work. In this case, we gave it two numbers, but it's not working. But that's because sum says, hey, you gave me an integer, you gave me some integers, that's not what I want. I want something called an iterable. We'll learn about iterables later on. Okay, we don't have to worry about that yet. But basically, this sum thing is looking for something else. It's not looking for integers, right? And we're going to look at that very, very soon. Let me clear that up. Okay. So just remember this error that we had, sum. Sum, we tried to do it, and now it doesn't work. We're going to fix that ourselves very soon, later on in the lecture. There's another one called round. Round is basically going to do the rounding. So if we get round answer, and we try to round a number, like 3.14, if we, so we're going to print that too. Print round answer. What's going to be the answer for this? We're going to round something. Okay? We're going to round an answer. Rounding in math is you look at the decimal place to the right and see if that 3 is going to be stay as a 3 or go into a 4. So what's going to happen here?
You'll get 3.
We'll get 3 because we're rounding up. Or sorry, we're rounding to the 3. If we call this 3.64, we run it, and we get 4. Okay? So Python knows I know how to round, and I do it with this function called round. Okay? Len. Len's a really cool one. Len is short for length. Okay? Len will give us the length of something. This is going to be very important coming up in PAs and stuff in the future. But len answer. Len is basically going to read something like Ismail. It's going to give back the length of whatever was in there. Len answer. We run that. Oh, whoa, 4. Whoops. There, remove that. Len answer. 6. It gives back 6 because the length of Ismail is 6. 1, 2, 3, 4, 5, 6. Ismail is 6 feet tall. Nice. Cool. What if we put Audrey? 1, 2, 3, 4, 5. Oh, 6. Whoa. That's wild. What if we put Nawa? 1, 2, 3, 4, 5. 5. Okay. Okay. So does everyone understand what length does? Length basically gets this and gives you back the length of something. Okay? Okay, cool. All right, so those are some built-in functions. Functions that Python already knows and understands, right? These are functions that Python already has all this pre-written code, right? How does it find the minimum between two numbers? We don't have to know that. Python already knows that using this function, right? So we can also write our own functions, right? Remember when we tried to do sum, and then sum gave us like an error, and it's like, that's not what I was looking for, right? It's because functions are very specific on what they want. But what if we want to do that, right? What if we wanted to sum two different numbers? We could do that by writing our own functions, right? Okay. So how do we do that? To write our own functions, Python, you have to be very specific about how to create a function. Okay? So to create your own function, Python has these specific words that are used to create your function. The very first thing you have to write to make a function is def. Okay? def. Oh, whoops. There we go. def. This def means that you're telling Python, Python, I love you. I need you to make a function for me. Okay? And Python says, great. Let's make a function. Right? This is going to say, we're going to define something right now. We're going to define a function. And we can name it whatever we'd like. Okay? We can name it some sort of name. Let's name, yes?
Can you name it sum, or is that like taken away?
That's a great question. So, as we saw before, sum is its own thing. Or len is its own thing. Round is its own thing. Right? Why don't we try that out? Sum. Right? Oh, geez. Actually, we'll try that out really, really soon. But the answer to that is you could do it, but it's a very bad idea to do that. Okay? It's a bad idea to basically create a new function with a function that's already existing within Python. Okay? And this gets into really advanced topics, and we won't get into it in this class at all. But basically, there are some functions that you can like overwrite and make it new things. There are some functions that get really mad at you and say, no, 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 you can't do that, right? But we won't get into that right now, okay? But DEF. DEF is how we want to start a function. And let's say, sorry, I put right here as a comment, I want to write a function to calculate discounts for a store, okay? Let's make a function that calculates discounts for a store. So if we want to make something to calculate a discount, we need to give it a name, right? We need to give our function some sort of name. Let's call it calculate discount, okay? Calculate discount will be the name of our function, all right? And I also put a little underscore here because when you're writing your function name, it all has to be one continuous sequence of characters. So if I try to do this, if I try to do this, that would not work. It needs to be all one continuous sequence. Does that make sense so far? Yes? Okay, great. Excuse me. So now, we have our special word called def. We're saying, Python, we're going to make something. We're going to make a function. Python says, great. What are we going to name it? We gave it the name. Calculate discount. Okay, great. Let's make that function. But what is something that we can see from all the functions that we've created before? Is there something that looks similar across all these functions? So we have sum, round, length, we have min here, and we have max. Look at all these functions. What is something similar about all these functions?
Parentheses.
There are some parentheses, right? Length, open and close parentheses. Round, open and close parentheses. Sum, open and close parentheses, right? Functions need this, right? Because functions, as we said before, you need to give it something, right? You need to start to give it something so you can do something with it. And the function's going to know what it is you're giving it by using these parentheses. So we need to have a open and close parentheses, right? But when you're creating your function, like when you're making it for the first time, right? Calculate discount does not exist within Python. We're making this for the first time for ourselves, right? So Python needs to know, what do we want in here? What are we looking for? Remember when we tried it with sum, and sum said, whoa, 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 whoa. You're giving me something, and I do not want that, right? Because functions get very picky. So we want to put something in here, right? So let's call this, what do we want to give it? We want to give it some sort of initial price, okay? Whatever you put in here, when we're creating these functions, are going to be variables, okay? Variables that are going to exist within our function that we want to work with, okay? So let's say we're going to start off with some initial price to calculate a discount, right? And then what you do is you put a colon, dot, dot, colon. This colon is telling Python, okay, we said we're going to make a function together. Python says, cool, what are we going to name it? We're going to call it calculate discount. Okay, great. What are we going to get from the user? What are we going to get to do something with it? We're going to call something initial price. Did I spell that right? Initial price, right? This is what we're going to start out. This is what we want to get. We want to get some sort of initial price. And then Python says, okay, great, are we done? Yes. The little colon means that we're done, okay? To start writing this function. So then what we do is we click enter. Whoa! We've always been writing stuff and it's been all the way to the left, right? But now for some reason the cursor is like a little bit inside. Okay? This is very important. I want you all to really understand this. For Python specifically. For Python, it is very important, these little spaces. Okay? Python knows that, remember when I said that when you have a function, it's going to do a bunch of magic things and it's going to give something back to you? Python's going to know when to start and stop doing all that magic by by this little space right here. So, what does that mean? That means that anything that we have inside here, let's start off our function by just doing something very simple. Something that we've done before, we've printed before, right? So let's print something out. Let's print a sentence. We will calculate a discount for you. Cool. Great. Let's do that. So we click enter. Again, we're inside here. We have some spaces and now it's inside. Do you see how this prints is kind of indented inside? Does everyone see that? That means that anything that's inside here is going to be called calculate discount. Okay? So let's say I'm done with making my function. I want to finish this right now. All right? What I can do is I can just remove the indent. I just click delete once and it did it for me automatically. And now we're all the way to the left again. Okay? That means that we're done with our function. We don't want to add anything else. And now Python is going to say, okay, great, now you have this function called calculate discount. You want to get a price, and we're going to calculate a discount for you. Okay? Python knows that we want to start using this function by calling it. We basically have to shout out loud, calculate discount. Okay? And the way that you do that is you just write it out here in your file. Calculate discount. Right? We want to calculate a discount. Let's shout it out loud for the world to know. We're about to calculate a discount. Nope. What happened? I said calculate discount. It says right there, calculate discount. Why am I getting some sort of error?
You never added like the initial price.
That's right. Remember when I said that functions are super picky? They get really, really mad. And they say, if you don't do it exactly how I want you to give it to me, then I'm just gonna stop. Okay? Right here, we said we're gonna give it an initial price. We're gonna give it something, right? And we never gave it to the system. So let's say our initial price is something that costs 27 bucks. Okay? Let's run that. Ooh. We will calculate a discount for you now. Okay? So now, what we're seeing is this. We wrote a function, right? We told Python, we're gonna make a function. We're gonna call it calculate discount, and I want you to not run unless we give you something. Something we're gonna call initial price. Okay? And we're gonna say, cool, let's start it off. Python says, great. What's the first thing you wanna do when you use the function called calculate discount? I said, well, the first thing I wanna do is print out something. We will calculate a discount for you. That's awesome, right? We run it, calculate discount. We give it some sort of price, 27. And what Python says is, okay, I see calculate discount. Let me go to wherever calculate discount is. It's right here. And I'm going to start running whatever's inside this little space. Okay? Whatever's inside this little space, I'm going to start running. And so all we had was print, we will calculate a discount for you. That's all we had. Okay? What if we want to put more stuff in there? Right? We didn't do anything with this initial price. Let's at least print out the price. Right? Just to see what it is that we're giving the system. So when we go over here at the end of the print, right? We went to the print, I just clicked enter. I clicked enter, and it's inside here, right? It's got these spaces again. It's got these spaces. Because we're saying we want to do more things inside this function. Let's print out your initial price is initial price. Right? So now it should say we will calculate a discount for you. Then it's going to say your initial price is whatever it is that we called initial price. Right? In this case, initial price will be 27. Because we're giving it some number. We're giving it the number 27. Calculate discount grabs that number 27. And it's going to say your initial price is, here it is, initial price 27. So let's run that. Oh, something went wrong. What went wrong here? It says here, type error. Can only concatenate string, not int, to string. What did we learn yesterday?
The type change.
The types, right? You need to add types together. You can't add an integer with a string. You can add a string with a string and output it, right? So why don't we make initial price into a string? How do we do that?
str and then parentheses.
str and then parentheses. That's it?
You have to add another one on the other side.
Ooh, you have to add another one on the other side. Thank you. Let's run that now, see what happens. Haha. We will calculate a discount for you. Your initial price is 27. Right? And now, if we want to change the initial price, we can do that as many times as we want. 100. Now it's 100. We want to make it 30. Now it's 30. Right? Does that make sense so far about how this function is working? Or is anyone confused at all? No questions? Okay? If you have any questions and you're a little bit nervous about asking a question, you can also use the EdSTEM discussion thread about it, okay? So, now we have this discount, right? We have this number, initial price, right? And just to really quickly show you how important it is to have these spaces, right? Just a little quick, 1, 2, 3. This is just a little quick aside. These spaces are super important because now I have these spaces up until here, but now this space is not really lined up, right? It's not lined up. And then when we run that, we're gonna get this error. Indentation error, right? Python's gonna get really mad at you because you didn't put all the indentation exactly how it has to be. So let's put it back. Right, let's run that again. Okay, our initial price is 30. We're good, okay? Let's say this calculate price, this calculate discount for a store. We want to calculate a 10% discount, okay? Let's say we want to get a 10% discount. If we have $30, right? $30, a 10% discount on this would be what? First we need to get, what's 10% of 30?
3.
10% of 30 is 3, right? It's 3. And then we subtract that together to get 27, okay? That's how we can get this 10% discount. One way that you can calculate that 10% discount is using some math, right? If a 30 is 100%, if you take away 10%, that's 90%. You're trying to look for 90% of whatever your initial number is, right? So now, what we can do is initial price times 0.9, okay? 0.9 is going to give us 90% of the initial price, which means that we're taking away 10%. Does that make sense so far, mathematically? Yes? Okay, great. So, now we have initial price times 0.9. We're basically taking 10% off, right? What's going to happen when I run this? Let's run it. We will calculate the discount for you. Your initial price is 30. What happened? We never saved this calculation anywhere, right? We didn't put it in a variable. We didn't print it out. We didn't do anything with it. It just went out into the ether, right? It's gone forever. So we need to make sure that we're saving that, right? So let's make a new variable called result, right? Result. Now let's run it. Oh, okay. That's not working. We need to print it out, right? We need to print out whatever this is. So let's print our result. Let's run that. Boom! All right? We gave it the number 30, right? With our function, we said we're going to calculate a discount, or we're going to start off with 30 bucks, right? Python gets that 30, says you got it, let's go to calculate the discount. It goes all the way up here, and it says we're about to calculate a discount, and my initial price is 30, because we gave it that number, right? So then it goes into here, inside this indent, right? Remember, it has to be anything that's inside this indent, it's all going to run, all together. So the first thing that we did is, we will calculate a discount for you. Awesome. Now, your initial price is whatever the initial price was. This initial price, 30, right? Then, we're going to calculate that 10% discount, 0.9. Okay? Since we calculated 0.9, we put it into the result, and now we're just printing out the results. And we're saying 27. Okay? Does that make sense so far to everybody? Yes, question?
How do you like prevent it from like taking in a string? Like,
How do you prevent it from taking in a string? That's a good question. That is something that we're not going to have to worry about for the rest of this quarter, right? But if you'd like to know, one way that you can do it is you can actively tell the system, you're telling Python, I want you to give me an initial price, but I want it to be a string. You go, sorry, I want it to be an integer, or a float, or some sort of number. But you're going to force it to not be a string, right? One way that you can do it, I think, the way that you do it is with a colon like this, like that. Is this the way that it's done? Why don't we figure this out together right now? How to make sure that a Python function takes in an integer. Look that up. Yes. So you have your function, you have some sort of number, and you're trying to make sure that it's an integer, right? So you have this little colon, integer, so when you run it, it works, but if you have it as a string, it's going to get mad at you. It's saying, whoa, I was looking for an integer, you did not give me an integer. I'm very mad right now, and I'm not going to run, okay? But, again, thank you for the question. We won't really have to worry about this going forward. Going forward, we could just assume that the user is going to be doing exactly what we'd like. But to answer your question, if you want to force the person to be an integer, or to give you an integer, you can just put colon, space, and then whatever you want, int, or let's say float, right? What if we want it to be a floating point, no matter what? Float is going to be able to type convert it for you. So basically, if you could do that type conversion, it'll do it for you automatically. So it got the integer, 30. It said, well, 30 is an int, but they're looking for a float. Let me help them out and make it into a float for them. And it worked out that way. Initial price is 30, 27. Okay? Does that make sense?
yeah, thank you.
Awesome. Great. Thank you for the question. All right. So now, how much time do we have? Oh, geez. Man, sorry, I have like 17 minutes left-ish?
Oh, it ends at 1:50.
1:50?
It's 1:33.
Oh, yeah, 17 minutes left. Oh, boy. I have been on this. Okay, sorry. So now, we're going to look at actually calling a function. So we actually just called this function. So remember, right here, so this is where we create our function, right? We created it. We created something called calculate discount. And it's going to do all this whenever we want to calculate a discount. But in order for this to run, we have to call it. And I've been calling it this whole time. But let me see what happens when I don't call it. So to call a function is basically to say it by name, right? You have to give it its name so it knows that you're talking about it. Calculate discount, right? And when you call calculate discount, you're also going to give it whatever it's asking for. Here it's asking for an initial price, and we're giving it 30, right? So when you say the name calculate discount, Python is going to say, whoa, calculate discount, I've heard of calculate discount. I'm just going to look for it somewhere. And then calculate discount, Python said, I found calculate discount. Calculate discount's at line, here's the line 74. At line 74, I found calculate discount. Okay? And then once Python says it found calculate discount, it's just going to go inside whatever calculate discount is, and it knows that with these spaces, right? This has 4 spaces. This other thing has 4 spaces. This has 4 spaces. So anything that's inside here is going to run it. All of it is going to read all that information. So we can call it over and over and over again. So now instead of having to copy paste all of this anytime we wanted to calculate a discount, instead of copy pasting it with 30, copy pasting it with 40, 50, right? Now we can just say calculate discount, calculate discount again. And now let's do a different number. What number do you want, Shahui? Any number you want. Very large even.
1,200.
1,200? Man, that's a good number. Let's run that. So now we see that when we get to this line, calculate discount, 30. Python says, you got it. I'm going to go and get this 30. I'm going to go up here. I'm going to start doing it. We're going to calculate a discount for you. We will calculate a discount for you. Your initial price is 30. And then we print out the result, 27. Great. Then it finishes up. Then we go to the next line. Calculate discount, 1,200. Right? Now, Python's going to say, oh, you got it. I know where calculate discount is. I'll go. Now with this new number, 1,200, we will calculate a discount for you. Your initial price is 1,200. And that's the resulting price, 1,080. Does that make sense? Yes? Okay, great. So, okay, great. So, let me see. Is this the next spot? Oh yeah, we wrote our own function, our control flow. Okay. Okay, great. All right. So in terms of control flow, what I said was, we get to this line, we say calculate 30, right? It gets to 30, it goes up there, and it runs it. Then we look at here, 1,200. Calculate discount, 1,200. It goes and it runs everything inside calculate discount, and it does it again, right? What happens if I do this? Wow, that's a cool discount. Let me do that again. What's going to get printed out here? In here.
It'll print like the wow in between the 27 and the we will calculate.
Okay. Yeah. So let's do it line by line. Python's reading the file. It gets to line 80. We say calculate discount 30, right? Then it's going to do these 3 lines. We will calculate a discount for you. Your initial price is 30. 27 is the result, right? Then it finishes. Then it goes into this next line. Now it's just going to print immediately. Wow, that's a cool discount. Let me do that again. Then it's going to calculate another discount, 1,200. So let's run that. It's exactly that. We calculate the discount for you. Initial price is 30, 27. Wow, that's a cool discount. Let me do that again. Then it calculates the discount again for a different number. Does that make sense? So this information within the function, all these lines of code, right? Everything that's inside of the function will only and strictly only be read unless it's being called out, right? And you can call it over and over again. You can put stuff in between, but Python's going to know now. Calculate discount is right there, okay? So that's the control flow in functions. Let me see, control flow in functions. Printing and returning. Okay, let's do that. So, as of right now, we are printing out here 27, right? And it's working out perfectly. That's what we were looking for, right? Because when we calculate the discount, let's do it again. We'll calculate a discount for you. Your initial price is 30, 27. Right? That's the result. That's the result that we're looking for. However, what happened last time when we would do this? Max 30, 27, right? We're supposed to be getting, this is supposed to give us 30, right? The max between 30 and 27 is 30. Let's run that. And we don't see anything, right? Even though we know that the answer is 30. But in order to look at it, we have to store that somewhere, right? So max answer. And then we print that out. Print max answer. We run that. And now we see that the max answer, right? This right here was 30. Because the max between 30 and 27 is 30. Now, it did this Because what max is doing, max, it is returning a value to you. Okay? It is not printing something, it is returning something to you. We're about to find out what's the difference between printing and returning. Okay? Printing something is you telling the Python system, I want you to say something out loud, right? I want you to say something. I want you to say the result, 27, okay? And it's going to say it out loud. That's all it's going to do, okay? It's not going to give you something. It's not going to give something back to you. It's just going to say 27, and it says it out loud in here into the console, right? What if we wanted to store that 27 in here? So discount result, right? We're trying to store something in there. We run it. Whoa, that's awesome. Let me print out discount result again because I like seeing that 27 so much. We run it. Oh, none. There's nothing there. Okay? Calculate discount is doing something. It's printing something, but it's not returning something. Okay? When we return something, we need to use the actual specific word called return. So here we have print, but instead of print, we want to return. Okay? Return is another one of those special words from, here we go, calculate discount 30. Okay. Return is another one of those special words that Python uses. Okay? Return is you telling the function, or you're telling Python, I have, so looking at all these special words that Python has. Def, you're telling Python, hey, I want to make a function. Python says, awesome, what's the name? It's calculate discount. That's awesome. What do you want me to get for calculate discount? I want the initial price. Awesome. When are we going to start doing it? What's the little colon? And we start doing everything inside here. Okay? I'm going to run all of these things anytime we call calculate discount. And now we have this new word called return. Return result. What return does is it gets whatever is on the right side here. In this case, it's the result. It grabs it. This is our result. Our result is this, right? It grabs the result and it's going to give it to you, right? Let's assume, Tyler, say calculate discount. Say it out loud.
Calculate discount.
Okay, I'm calculate discount. I went and I did something and I got this. Here's your result.
Thank you.
Right? I didn't say anything out loud. I did all my work, I did everything, and I gave it to Tyler. Okay? Because Tyler called out calculate discount. So that's what it's going to look like here. Now that we're returning something, we're returning the number, the result. We should be returning 27. When we run this, we say we will calculate a discount for you. Your initial price is 30, but now we don't see that 27, right? We don't see it anywhere. Because now, what I did, I'm not saying it out loud. I'm not saying out loud what the result is. I'm grabbing the result and I'm giving it somewhere, right? But right now we're not storing it anywhere, okay? The way that we can do that is we do this, right? We're going to get the calculate discount, right? So now, when we call calculate discount, it's going to grab whatever the result was, give it to whoever called it. Tyler called it. I went and I gave that result to Tyler. And now, it's stored right here in this variable called discount result. So now if we want to see it, we could print, or sorry, first, let's run that. What happens? Nothing happens because we need to print out discount result. Okay? Here's our discount result. Let's run that. Boom. Now it says 27. Because now, this function got the result, it grabbed it, it gave it to someone else, right? It gave it to discount result. Discount result now has that result that we calculated, right? It grabs it, and now Python is saying, I'm going to say out loud whatever discount result is. I'm going to print it. And it says 27, okay? Because that's what it found. Does that make sense to you all? The difference between printing and returning? Printing is saying something out loud. You're not giving any information anywhere. You're just saying it out loud, right? Return will grab whatever that result is and give it to you, okay? It'll give back information. And of course, you have to hold that information somewhere. When we called it without holding it into a variable, yes, the function, it grabbed something and it threw it, but it didn't get stored anywhere, right? Because we didn't hold it. And now we're holding it with variables. Does that make sense? Yes? Okay, great. Let's see, what's the next thing? Yes, printing versus returning. Okay, end of lecture. Whoa, cool. Let's make this a little bit more involved, right? Let's say that now we want to add tax, right? We want to add the tax to calculate the discount. Yes, you got the discount. You started off with 30 bucks. We took away 10%. Then it's 27, right? But now we want to add a tax, right? What is that tax? We can make that tax whatever we want it to be. Here, we can say here, we have the initial price, we take away 10%, 0.9. But now, so let me see, so let's say discounted result is the initial price, right? But now let's say we want to add an 8% tax, right? Because 8% is the typical sales tax that we have in California. So our new result is going to be a discounted result, and we want to add 8% to it, right? So what we can do is add whatever that discounted result was. Oh, sorry, discounted result, right? But we only want 8% of it, 0.08. Let's get 8% of whatever the discounted result was and add it back into our final result. Because ultimately we all have to pay taxes, right? So we run that here. Let's run it. So now, instead of 27 bucks, it's 29.16. Because we started off with 30, we did take away 10%, but then we have to add the sales tax back into it, right? And we taxed the discounted result, and that's 8%, right? Does that make sense so far about what I'm talking about? Anyone confused so far? Yes, no, yes, no? No? Okay, great. Why am I bringing up sales tax, right? Sales tax in California might be 8%, right? But what if you're somewhere else and they charge 9%, right? And then you run your program, it's like, okay, that's 9%. What if somewhere else actually doesn't charge tax at all, right? And we're back at 27. One way that we can do that to make sure that when we're calculating the discount, we can also take into account what that sales tax will be. What we can do is, our function, instead of just asking for one thing, we can ask for two things now. And the only thing you have to do now is add a comma, and then the new name for something that you want. Let's call it sales tax, right? Let's call it sales tax. So now, no matter where you are, what you can do is you can take the sales tax into account. So now you'll get your final result with the sales tax wherever you are, right? In California, it might be 8%. In New Jersey, it's some other percent. In Delaware, it's 0%. Lots of different states have different regulations, right? And what we can do with our program is make sure that it doesn't matter where you are, as long as we know what your sales tax is, we'll calculate it for you. It doesn't matter what state you're in, right? And what we can do that with is with this little comment. And we're saying this function now not only wants an initial price, but it also wants a sales tax, right? So now when we run this, ooh, it got mad at us, right? It got mad, it didn't do anything, because this function says now the only thing that I need is not just the initial price, I also need a sales tax, right? So now our sales tax, we can call 0.08, right? We're getting the 8% sales tax added onto it. And now when we run it, that works now, okay? Does that make sense to everybody? Yes, no, yes, no? Anyone confused? Anyone tired? Yeah? Anyone want to go home? Anyone want to finish their PA? Yeah? All right, well, I think that about does it for our lecture for today. If you have any more questions about printing and returning, what functions are, how they work, make sure to ask me or anyone on the staff team at all on EdSTEM, on the EdSTEM discussion, or go into office hours. Okay? You could also use code help to ask questions like, I'm really confused about this. For example, that question that you had of, well, I don't know how to force it to make it be an integer. You can also ask code help as well, and they'll give you step-by-step instructions on how to do that. Okay? That make sense for everybody? Awesome. Well, thank you so much, and we'll see you all tomorrow, and hopefully later on today with discussion with Chahui. All right, awesome. Thank you so much, everybody. Great. Also take some granola bars to go, please.
Thank you.
Of course. Oh, actually, I mean, I'll tell you later. But remember when we were doing the sum in the EdSTEM, in the lesson where it said for our lecture 3, there is a place for you to start writing up your own function called add. So you can add two different things together. Sorry about that. I forgot I took over that. Y'all go on here. All right. Done. How was that? Was that all right?
Great, yeah.
Yeah, cool. Did that make sense? Did I say something that was a little confusing at all? I feel like I messed up there when I was talking about sum. I could have sworn that we were talking about sum, and then I saw iterable, and I was like, uh-oh, we're not supposed to be doing this yet, not lists, right? And then that happened. But other than that, was that all right? Anything you all would change at all? No?
The pacing was good. I like the pacing.
The what?
The pacing was good.
The pacing? Okay,
Yeah.
cool. Awesome. Great. All right.